Hello everybody. I'm with a company called Agent Video Intelligence, and we've been developing video analytics solutions for over a decade. And today I'd like to propose to you a novel concept for taking video surveillance cameras and using them to make our cities safer. So I'd like to start with talking about something that we call the video blindness paradox. And basically what we've seen is that the more cameras we deploy, actually the less we see. So in the past, when there were small numbers of cameras, a few operators could actually watch them. But as numbers increase, the amount of time an operator can spend on a specific camera has decreased until it has become practically zero. So these days, most of the cameras that are being deployed are basically not really providing any benefit. So the video is captured, it's stored, and then a few weeks or months later it's deleted with nobody ever watching it. This is especially true in cities. So I would say a few years ago, if you looked at typical video surveillance projects in cities, you would have seen projects with around, in the neighborhood of hundreds of cameras. These days, the numbers of cameras being deployed are growing to thousands and tens of thousands, and if you look at China, there's cities with hundreds of thousands of cameras. So the amount of data being generated is constantly growing, and again, as I mentioned, that data at the end of the day right now is not really doing much or giving us much benefit. So how do we solve this? We naturally turn to AI. So the ability to process video, detect objects, and track them has been around for quite a while. But I would say that only in the past 2 years, the technology has matured enough for us to be able to do this accurately, very, very easily, and most importantly, at scale. So these days, we can take an algorithm, feed it with a live stream from a video camera, and have that algorithm, first of all, detect every object of interest in the field of view. And for each object, it can tell us different attributes. So where that object is, how fast it's moving, what it is it a person, a bicycle, a truck, and so forth. And then additional attributes. So if it's a vehicle, we may be able to capture the license plate, or at least part of it. If it's a person, we can capture facial characteristics, and so on. But this is just the first step. Because when we do this process on 1,000 or 10,000 cameras, we still end up with way too much data. So this data right now is not pixels in video, it's already objects, but there are literally hundreds of thousands of these objects at any given moment, and obviously a person cannot really do much with that. So we still need further processing. And what we're doing here is we are introducing a secondary AI. So this AI, instead of looking at the video, it's now looking at the metadata that was generated by the first stage. And we're actually collecting this data over a period of weeks and months, and then using machine learning to build behavior models that are specific to each and every camera, and also to groups of cameras. And once these models are built, we can then use the algorithm in real time to analyze the metadata coming in and identify anything that's out of the ordinary. So out of the ordinary can be a specific object that's behaving out of the ordinary, or it can be a group of objects that together are behaving out of the ordinary. And once we identify this type of event, then only those events get pushed to the users. So this means that a relatively small number of users can actually be monitoring a very large number of cameras, because the software is doing most of the work for them and really allowing them only to focus on the relevant information. So let's take a hypothetical example of how this would work. So we have a typical city, and then sometime in the morning, the AI picks up a vehicle that's parking on the sidewalk. And then a few minutes later, we detect a crowd of people running away from the area of an underground station. And a few minutes after that, we pick up a vehicle driving against the flow of traffic. So all of these events were automatically detected, but the AI can now correlate them. And it can come to an understanding that the vehicle that was parked there is actually the same vehicle that's speeding away. And since that event happened in the vicinity, it can push all this information proactively to the user and really allow them to get situational awareness much quicker. And then if the user decides that he wants to actually investigate and find out where that specific vehicle is, well, since we are tracking and identifying all the objects in the field of view of all the cameras, then any time that that vehicle will pass through one of our cameras, we will be able to identify it and then again push an alert to the user and tell them where that vehicle is right now. So that's basically all I have for you. And if you'd like to hear more about this, we're at the Israel booth and you're welcome to visit us.